Hello, good morning students. So welcome to the online video class. So again we're continuing from the same chapter, overview of C++ from the unit introduction to C++. So in today's video we'll discuss about how you declare a variable, okay, how you initialize a variable, and what are data types, okay, and what are the rules for naming a variable. So this is continuation of the previous video. Okay, in the previous video I discussed about the character sets, tokens, keywords, and what are variables, the definition of variables. Okay, so if you have not watched the previous video, watch the video and then only you can understand this video. Okay, so variable declaration, how do you declare a variable? Now, until and unless a variable gets declared, okay, the compiler will not allocate any memory space for that particular program. Okay, so it is not able to run the program. Okay, so variable, it must be declared before they can be used. So before a variable is used in the program, it has to be declared. That means declaration is telling the compiler that that particular variable is going to be used in the program, and so it is telling the compiler that okay, allocate memory space for that variable. Okay, and keep in mind that the variable is a user defined name. Okay, so it is declared at the starting of the program or can be declared anywhere before being used. So usually, okay, right after the main function, uh, the variable is declared. Okay, all the variables are declared before the program at the beginning of the program. Okay, or it can also be possible that okay, the variable can be declared just before the variable is used anywhere in the program. Okay, later on you'll get familiarized with this sentence, okay, when you start the program, but only just keep in mind that a variable must be declared before it is used. Okay, now a data type is used while declaring a variable to determine the memory space allocated to the variable. So what is a data type? Okay, so using the data type, I've explained that also, okay, in the previous video. Okay, so using the data type, okay, it helps to determine, okay, how much memory space will be allocated for that variable. So if your data type is integer, okay, so it can be for the integer, the variable can be allocated anywhere from 2 bytes to 4 bytes. Okay, or if it is for a decimal point value, for a float or a double, it can be 4 bytes of memory or 8 bytes or 10 bytes also. Okay, so a data type is always used, or it is always written before the variable name, okay, so that to tell the compiler, okay, uh, how much memory space will be allocated for a particular memory. So the data type and the variable name is always written side by side in the program. Okay, now you can see here an example. Okay, int salary. So int is the data type. Okay, it is written just before the variable name. So here salary is the variable name. Now if you don't, if you can also write, instead of salary you can write sal. Okay, so or you can write salaries. Okay, and it is ended by a semicolon. So semicolon denotes that, it tells the compiler that this particular line of statement uh, is terminated. Okay, and then move on to the next line of statement. That is, semicolon in C++ is used like a full stop or a period in a sentence, okay, to denote that that particular sentence uh, is finished and move on to the next sentence. Okay, so a semicolon is also used in the same way after every line. Okay, so here int is a data type, which is a keyword, but variable salary is not a keyword. Okay, this is a user defined name. So this is a normal declaration. So this tells the compiler that okay, this tells the compiler that the variable name is a user defined by the name of salary, and it is of integer data, data type. That means this variable salary will store integer value, that means positive or negative numbers. Okay, so the compiler will allocate 2 bytes or 4 bytes of memory for this variable salary. Okay, now variable initialization. So a variable can also be initialized when it is being declared during the declaration. So what does it mean? So initialization is done by assigning values to a variable. So here in this example you can see that, okay, int salary equals to 10,000. So what this line statement is saying is that 10,000 is stored in the variable salary. Okay, so here using the equal to sign, which is an assignment operator. Okay, so from the right to left, 10,000 will be stored in the variable salary. Okay, so this particular line statement, okay, in this particular line statement, the value or the data is already pre-written in the program itself. Okay, so user does not need to enter from the keyboard uh, the value for the salary, the data for the salary. But when it is written here in salary equal to 10,000, that means it is already defined in the program how much, what the data for the salary variable is. Okay, so 10,000 will be stored in the variable salary. So this is called as initialization. Okay, so a note, uninitialized variables are given garbage value. Okay, so it means that, okay, uh, when you are declaring a variable, okay, and not assigning any value, and then later on, okay, in the program, if that variable is called for without being assigned a value, okay, suppose like salary, okay, if the user if initialization is not done for the salary, that is just declaration in salary, and if suppose the user does not enter from the keyboard the data for the salary variable, okay, then what will happen is that when the program is run and the output gets printed out, okay, since proper declaration and initialization is not done for the salary variable, a garbage value will be assigned. Okay, so what is garbage value? It will be explained in detail more in the coming chapters. Okay, for now just understand that garbage value is a random value that will be assigned to the variable based on its data type. Okay, so in this case, since the salary is data type is integer, so a random integer number, so could be 42, could be 1000. Okay, so any random value, can integer value, will be printed out on the monitor screen. Okay, so that is a garbage value. Okay, because it is giving a command to the compiler, okay, to print out the data. Okay, so since no data is assigned, okay, so the garbage value will be printed out. In the case of a data type, suppose like decimal point value, okay, so decimal output will be printed out as a garbage value. Okay, so what are the rules for defining a variable name? Okay, so there are certain rules that must be followed when you declare a variable or when you use a variable in C++ program. Okay, first thing is variable name should be as short as a single letter. The variable names cannot be written long. Okay, yes, it can be long, but only the first 232 characters are will be considered or printed out. Okay, so a variable name should be as short as possible. Okay, uh, equivalent to just a single letter or say like a word. Okay, next is variable name must always begin with an alphabet. Okay, it is compulsory for a variable name to begin with an alphabet or an underscore. Okay, but uh, most preferably it should be start with an alphabet. Okay, then after after the second step, okay, it can contain different alphabets, or it can contain numbers, or it can contain more underscores. Okay, it cannot be reserved word. So a variable cannot be a reserved word, because a variable is a user defined name. Okay, no blank space are allowed between variable names. So the it was in the earlier video, as I mentioned, that compiler ignores blank space except in certain cases, right? So in the case of variable, if the variable names has two words, there cannot be a blank space between those two words. Okay, I've mentioned an example to make you understand regarding this particular no blank space allowed. Okay, next is only one special character underscore is used. So only one special symbol can be used in for declaring a variable, that is the underscore. Okay, so uh, here are some examples of valid variable names. Okay, so here you can see that roll number, okay, roll underscore no. So here you are using the underscore in between to differentiate roll and number. And then again, roll underscore number 1. Okay, or you can also write roll 1 underscore no, or roll number with no gaps. Okay, now these are some of the invalid variable names. Okay, 1 roll underscore number, here it starts, the first one, it starts with a number. Okay, it cannot start with a digit. A variable name cannot start with a digit. Okay, in the second case, roll number, now you will notice that between the roll and number there is a space. Okay, so blank spaces are not allowed in variable names. Okay, so that will result in compiler displaying an error. And in the third case, int, so int is a keyword, so keyword cannot be used for a variable names. Okay, so variable names are case sensitive, that is, variable names, as far as possible, it should be written in lowercase. Okay, notice that I've written roll number R in lowercase letter, that is in small letter. Okay, so here is an example in terms of case sensitivity. Int marks, the first one variable is in lowercase alphabets, all the letters are in lowercase. In the second case, int marks, M is in capital, and in the third case, marks, all the alphabets are in capital. Okay, now if they are used differently, okay, it will not result in error. But if suppose the marks variable is used in the same program for the same purpose, in that case all the three variables will be identified differently. Okay, marks with small alphabet and marks with capital alphabet, okay, is different. The compiler interprets it different, and hence uh, if you have declared the variable marks in small letter, okay, and then towards the program, okay, you have used that variable in capital letter, okay, the compiler will display an error. It will not be able to identify the capital letter marks. Okay, so the variable which are declared, only those variables will be identified, provided the variables uh, are written with this same lowercase or uppercase letters. Okay, so next is data types. Okay, so data types, what are data types? So data type defines the memory storage allocated for the variable. So it means that uh, how much space will be used up by that particular variable, the compiler will allocate that much based on the data type. So if the data type is integer, it will allocate 2 bytes or 4 bytes. If the data type is float, okay, or real, it will allocate 4 bytes or 8 bytes. If it is character, alphabets, okay, it will allocate 1 byte as such. Okay, so it is used to identify the type of values a variable will hold. Okay, So with the help of the data type only, okay, user gets to know, or the program will know what type of value this variable will store. Okay, so when you declare the a variable of data type in, then the compiler understands that, okay, that particular variable marks will hold integer values, so it will allocate 2 bytes of memory or 4 bytes of memory. Okay, now a data type is divided into the following types. Okay, a fundamental, primitive, or built-in data types. This is the most basic data type. Okay, the symbol data type, or the fundamental data types. Okay, so this is the most widely used data type. Then next you have is the structured or derived data types. Okay, and then you have enumerated data types, pointer data types, and void data types. Okay, so all these data types we'll see in the next class. Okay, so if you have your textbook, in the textbook, regarding the fundamental data type, there is a table that is drawn, that is table 1.3. Have a look at that and check the range of the values. Okay, so in terms of memory size, it is written there like for short int it is 2 bytes, right? So how do you get that in terms of uh, 2 bytes, right? So what you can do is that you can divide the decimal point value, suppose like 32767. Okay, try dividing that by 2. Okay, so you get the binary value of that 32767, and you will see that you get uh, 16 16 values of zeros and ones. Okay, which is 8 bits, which is equivalent to 2 bytes. Okay, so that way you get the range of the size for the data types. Okay, so that we will discuss in the next class. So in the next class, the types of data types. Okay, literal constants and constants we'll see, and punctuators also. Okay, so that will be all for today.